Hello everyone, I am Adrenaline the Bazooka Prophet, CEO and Adrenaline Global Educational Consult, a platform that has spanned for over 15 years, helping students who are struggling with maths, chemistry, physics, and even biology. And we tailored our teachings in exam preparation for SAT exams, AP exam, IB exam, or any exams. Is it IGCSE or GCSE for students that are residing in the United Kingdom? We are actively in helping students all around the world globally. Now, in this particular video, we're going to be talking about a very important question in stoichiometry for students who are preparing for any A-level exams, be it IGCSE exams and GCSE examination. Now, what is the question in particular? As you can see on the board, right on my screen, the question says, calculate the molality of a 1.55 molar concentration of sulfuric acid. And you know that sulfuric acid is H₂SO₄, right? Solution of 1.18 gram per mil density. It is very easy. So let us go straight to business. As you can see the question on the screen, let us pick out what we are expected from the question. Now, firstly, you were given your molar concentration of the acid. Your molar concentration, which is your molarity, is given to you to be 1.55 molar concentration. You were given the density of the solution to be 1.18 gram per mil, and you were asked to calculate for your molality. I'm going to be taking my time to break this question down so it can be easy for you to understand and comprehend, because that is what we do in our platform. We make every questions look so easy. Now, first of all, what is the formula for molality? Molality is simply equal to the number of moles of the solute over the kilogram of the solvent. The number of moles of the solute divided by the kilogram of the solvent. Now, me looking at this question here, a lot of persons can be confused, but that's not the case. Don't worry yourself. I'll make it easier for you. Now, how do I get my number of moles? Do not forget that molarity that I was giving here, which is 1.55 molar concentration, is also same as 1.55 mole per dm cube, or mole per dm cube, right? Okay, so it simply means that 1.55 mole would dissolve in 1 dm cube, or even 1 liters, because 1 dm cube is equivalent to 1 liters. So from here now, I can get my number of moles here. So my number of moles here is already 1.55 mole. Now, where a lot of students often have issues is pertaining to the kilogram of solvent. Now listen, remember that solution is simply equal to solute plus solvent. So if I'm looking for my solvent here, solvent is simply equal to solution minus my solute. Now, how do I get for my mass of the solution? It was given for me from the question. Remember that density is equal to mass over volume, so that my volume is equal to, okay, so that my mass is simply equal to density multiplied by volume. Simple, without even talking much. Just know that my density is 1.18, right? Multiplied by, okay, 1.18 gram per mil. Just multiply it by 1000 mil so that you can convert it, so that mil cancel mil, have it to be 1180 gram. So the mass of my solution now is already in 1180 gram. Now, how do I get for my mass of the solute? It's simple. Now let's go. To get for the mass of the solute, remember basic number of mole formula. That number of mole is equal to mass over molar mass. I'm looking for my mass here. Mass is equal to number of moles multiplied by my what? Molar mass. My number of moles from the solute is 1.55 multiplied by the molar mass of my sulfuric acid, which is my H₂SO₄. The molar mass of my H₂SO₄ is simply equal to 98 gram per mole. For those of you who might be wondering how I did it, hydrogen has a mass of 1, so 1 times 2 is 2, plus sulfur is 32, oxygen is 16, 16 times 4 is 64. So when you add this molar mass all together, you should have it to be 98. So you come here to say 98. 1.55 multiplied by 98, it is 151.9. 151.9 gram. So I come here to say equal to 1180 minus 151.9 is equal to, okay, I subtract 151.9, okay. The answer is 1028.1. That's 1028.1 gram. Now, what do I do here? Simple. So my molality is equal to the number of moles of the solute is 1.55 over, now the kilogram of solvent. It means that I will have to divide this gram of the solvent to kilogram. So to convert gram to kilogram, you divide by 1000. So here will give me 1.0281. So that when you divide, you will get an approximate answer of 1.51 molar concentration. Not the one that ends with R, but the one that ends with L. Let me just write it: molar concentration, small letter m. That of the molarity own is capital letter M. And this actually marks the end of this particular video. Do well to like, share, and subscribe, and also tell your world to join our marathon classes. We also have one-on-one online private classes, which is tailored to any examination of your need. Thank you, and God bless you.